Being continuous is an important condition for many theorems in calculus. One that's introduced in this first unit is called the intermediate value theorem. The definition for intermediate value theorem that you see on your screen right now might look very complicated, but once you hear the basic idea behind it, I hope you'll realize that it's actually very intuitive. What it says is that if a function is continuous on a to b, so like my orange curve is continuous between x equals a and x equals b, then f of x, or the orange line, is going to take on every y value between f of a and f of b, or the y values for the endpoints. So you can see here that I highlighted the section of the graph that goes from f of a to f of b in the y direction. And you can see that the orange line actually hits every single y value in that blue section. So that's what intermediate value theorem is saying. The way intermediate value theorem, or IVT, is more typically used is described in the second little blurb on your screen. If there is a y value called k between f of a and f of b, so you see I just picked a y value that was in that blue shaded region, then there has to be an x value, and usually they just call that c, these are just kind of arbitrary, that falls between a and b that has that y value. So in other words, if you pick a y value, and that y value is between the y values of the endpoints, you're guaranteed that there's an x value between a and b, where if you plugged it in, you'd get that y value that you started out picking. So this theorem is all about proving that a y value must exist on a given x interval. For this reason, IVT is called an existence theorem. Intermediate value theorem, or IVT, is actually the idea behind one of my favorite math comics ever, which is this one, Why Did the Chicken Cross the Road? Well, the intermediate value theorem, of course. Unless the chicken teleported to the other side of the road, we have to assume that his path is continuous. So therefore, his path must go from f of a up to f of b, crossing the road along the way. So in many ways, IVT is a very common sense idea. This problem, taken from a past AP exam, shows the type of math problem that you might be asked to do where you use this theorem. For this problem, the text tells us that a car is traveling along a straight track, so that its velocity and acceleration are continuous functions, note that condition, and it gives us some selected values for both the velocity and the acceleration over the interval 0 to 60. And then it says, between 0 and 60, must there be a time when the velocity equals -5. And if you see something like, must there be a time, that's going to be a tip-off that you want to use an existence theorem. So essentially this problem is asking, is there a y value on the velocity graph that is equal to -5? And so since I'm talking about the existence of a y value, intermediate value theorem is the way to go. So the main thing I really need to look for is -5 between two y values for v of t? If you look closely at the v of t line of your table, you see that at 35 and 50, the y values are -10 and 0, and -5 is between those. Because v of t is continuous, which they told us in the problem text, that means it has to hit every y value between -10 and 0 during time 35 to 50. So the short answer is yes, there does have to be a time when the velocity equals -5. But the long answer is how you have to write it correctly. So first, you have to specify that v of t is continuous, because intermediate value theorem wouldn't apply if it wasn't continuous, because a non-continuous function could skip some y values. Then you have to explicitly state that -5 is between -10 and 0, or it's between f of 35 and f of 50. Therefore, and then you want to cite the name of the theorem, intermediate value theorem guarantees that there's going to be a t in that interval 35 to 50, so that v of t is -5. And since 35 to 50 is in 0 to 60, then there has to be a time when v of t is -5. So some takeaway points are this. IVT is an existence theorem that shows that a y value exists. In order to use IVT, you have to be able to state that your function is continuous. You have to state an inequality using the y values, and then you need to cite the theorem in your conclusion. If you do this, you'll always be successful on problems using this theorem.